Good afternoon to all the students. Today we have started our discussion on the quicksort algorithm. We have gone through some of the introductory parts related to quicksort algorithm. That is what actually the quicksort algorithm depends upon, right? And what algorithmic strategy that is used for quicksort algorithm, right? That is divide and conquer. Important points regarding this divide and conquer, and then we have gone through the pivot element. As I said, that the pivot element plays an important role in the performance of the quicksort algorithm. And we have seen different methods to choose the pivot element. And we have discussed why we require this pivot element. And what happens if we arrange the pivot element. All these things we have discussed, right? So can anybody tell me what is a pivot element? What is a pivot element? Somebody please respond. What is a pivot element? Anybody there?
Number in the sequence used to divide a series in two different parts.
Right. So a pivot element is an element, you can choose it from the given list of elements, and the purpose of the pivot element is when you arrange the pivot element in a particular place, then it will divide the given list of elements into two parts, right? One is towards its left hand side and the other one is towards its right hand side. And when you make the pivot element to sit in the correct position, then all the elements that are towards the left hand side are less than the pivot value, and all the elements towards the right hand side of the pivot element are greater than the pivot element. So for the purpose of dividing the given list of elements into two parts, we are making use of this pivot element. So we should select a good pivot element. How can you say that it is a good pivot or bad pivot? So a good pivot, when you make it to sit in the correct position, then it divides the given list of elements into two almost equal halves. So if such an element is chosen as the pivot, such that it divides the given list of elements into two almost equal halves, then we say that it is a good choice of pivot. And if it does not divide, that means if we have more number of elements on one side rather than the other side, then we say that this is not a good choice of the pivot. So when you select a good pivot, the performance of the algorithm will be increased. You sort the elements very efficiently, right? You get an efficient algorithm or you get an efficient result. So that is the importance of the pivot. And yesterday we have already seen this particular algorithm, the basic idea behind the quicksort algorithm. This also we have discussed. Right? The first step, what is the first step? We have to select the pivot element. And the second step is you have to place the pivot element. Listen carefully. This is important, right? We'll see it with an example. We'll implement this idea with an example, right? For this, you should know, or you should have some idea of this particular quicksort algorithm. The first step is you select the pivot element. Second step is you have to place the pivot element either in the leftmost end or in the rightmost end of the given list of elements, right? And as I told that this is an optional step. So if you select the first element as the pivot element, then there is no need to shift that element. If you select the last element as the pivot element, then there is no need to shift the element, right? But if you select any random number between the first and the last element, then you obviously shift the elements from that position such that it will go towards either it at the left part or in the rightmost end, right? So the second step is an optional thing. After you select the pivot element and you move it to one end of the array, you should take another 2 pointers which are called as left and right pointer. You just have to declare the 2-pointer value. And these 2 pointers, what they will do is the left pointer is to be pointed to the first element, and the right pointer is pointed towards the rightmost element, leftmost element and rightmost element. And you have to compare the element that is pointed out by the left with the pivot. Similarly, you have to compare the element that is pointed out by the right with the pivot. Any comparison, you have to make it with the pivot. So whenever you compare the left element or the element pointed by the left pointer with the pivot, the point here is you have to have the lesser elements than the pivot. So whenever you have lesser elements, you just leave it and increment the left pointer. So the incrementation of the left pointer should be done unless you come across a value or an element which is greater than the pivot. So the left pointer should be keep on moving the left pointer until you come across a greater element than the pivot. Similarly, when you go to the right, the element that is pointed by the right pointer, you have to compare that element with the pivot. And whenever we know the concept, right? The importance of pivot is it will divide the given list of elements into 2 parts, where the left part is always less than the pivot and the right part is always greater than the pivot. So that is the reason why when you compare the left part or left pointer element with the pivot, when it is less, you just keep on moving unless you come across a larger element. Similarly, when you compare the right element or the element that is pointed by the right pointer with the pivot element, when it is greater than the pivot, when the element is greater than the pivot element, you just decrement the right point. And you keep on decrementing the right pointer unless you come across a value which is less than the pivot. Right. So when you find an element which is less than the pivot element, then you stop. Similarly, when you find an element which is greater than the pivot by the left pointer, then you stop. So when you come across that situation where the left pointer is pointing to an element greater than pivot and the right pointer is pointing to an element less than the pivot, you just stop it and you swap those two values. You swap those two values and you continue the process. So this step is very important. We'll see with an example, don't worry. Right. So whenever you find these two elements, exchange them and then go on. This is step 4. What are these two elements? The first element is the greater element pointed out by the left pointer, and the second element is the smaller element pointed out by the right pointer. So when you find these two elements, you just exchange them and then you keep on moving. Right. At one point of time, this is very important. At one point of time, these 2 pointers, this left and right pointers, they will cross each other. They will cross each other. When they cross each other, now you have to stop the pointer, you have to stop the process, and you have to exchange the pivot value with either the left pointer or right pointer. It depends on the agreement. So whenever the 2 pointers cross each other, you just swap that pivot value either with the left pointer element or the right pointer element. Right. Is it clear?
Yes.
Right. So when you swap the pivot element with the left or right, left pointer element or right pointer element, then you made the pivot element to sit in the exact position. So by that time, you have reached a situation where the pivot has divided the given list of elements into 2 parts. The first part, the left part of The left part of the pivot is
ఇంకా రావట్లేదా ఆర్జ్ మనిషిగా పని ఆవేశకి వచ్చిన లోపల తీస్తావా నా ఫోన్ ఒకసారి జాగ్రత్త అందరికీ
so when you have made the point pivot element, when you have swapped the pivot with one of the element that is pointed by left or right, what happened here is the pivot has been placed in the correct position, and the elements towards its left hand side are less than pivot, and elements towards its right hand side are greater than pivot. Right? So this is what the step 6 is saying. So once you reach this position, you have to apply the quick sort on the left sub-array and right sub-array separately, and this process has to be repeated until unless the entire list of elements are sorted. So you have to apply the recursion method, and then you can implement the quick sort. Is it clear?
Yes, sir.
Now let us take an example and then we will try to implement the quicksort algorithm. This is very important. You just concentrate. Can anybody tell me some 10 random elements, 10 or 11? 11 random elements.
-7.
-7. Don't go for minus. We'll see that can also be applied. That's not an issue. But let's take the positive value.
2.
Okay, 2.
15.
What?
15, sir.
I'm asking you to give the random numbers. Don't give it in the increasing.
Yes, sir. 9.
2, 15,
9.
9,
60, sir.
okay,
That's something.
22, sir.
set,
22,
22,
7, sir.
yes, 17,
1, sir.
34.
So how many elements I have taken?
11, sir.
11 elements. So as I told that you have to read the list of elements from the user and you have to store it inside the array.
Sir, you took only 10 elements, sir.
Just give me 1 minute of time. Can you hear my voice?
Yes, sir.
Yes, sir.
So these are the list of elements we have chosen and we have stored it inside the array. We have 10 elements, therefore we know that the index concept starts with 0 and ends with n minus 1. So what is step 1 in quicksort?
Selecting
Choosing a pivot element.
Selecting a pivot element. So you can select the first element as the pivot or the last element as the pivot, or you can take the first element, last element and middle element. What is the middle element here? How can you find the middle element? You have to take the indexes 0 plus 9 by 2, that is 4.5. Either you can take the seal of 4.5 or the floor of 4.5. Better is not, right? Both are correct only. So if you take the floor of 4.5, what is the value? What is floor?
35, sir.
It is 5. What? It's not 4 floor, right? This is floor. This is 4. And if you take the seal, it is the 5, right? So let us take the seal value. So what is the index we got here? It is 5. Therefore, whatever element we have inside this fifth index, that is to be considered as the middle element, right? So you can take the first element, that is you can take 2. What is the middle element? It is 22. And what is the last element? It is 40. So what will be the median of these three numbers?
22.
22, sir.
22, right? Median means you have to arrange them in the ascending order and then you have to take the middle element. So this method, you can choose any method, but right now what I am doing is I am selecting the last element as the pivot element. You can take anything, right? If you take 22, for example, if you consider the 22 as the pivot element, what you have to do? So this is taken as pivot. So you have to implement the second step. What is second step? You have to throw this pivot element either to one end. Either you can throw it into through the first part or the leftmost element, or you can throw it into the rightmost element. Throwing is nothing but swapping. So either you swap this 22 with this element, or you can swap this 22 with this 40. So this becomes 40 and this becomes 20. This is how you make the pivot element to point to the last element. Is it clear up to this point?
Yes, sir.
Now you tell me what choice we'll make. Let us take the pivot as the median of three numbers or the last element. Choice is yours only.
Last element, sir.
So let us take the pivot as the last element. Therefore, we remove this and pivot. So what is step 3 now? What is step 3? I have to
Choosing
take
the left
2
and right.
pointers. Yeah, super. I have to take 2 pointers, left and right. And you make the left pointer to point to the first element, leftmost element. And you have to make the right pointer to point to the rightmost element other than pivot. Right. So right is pointing to which location? It is pointing to 8th index. Pointers are nothing but indexes. That's it. Right. So the left pointer is pointing to 0th index and the element is 2. Now what is step 4? We are done with step 1, which is selection of pivot. We have selected the last element as pivot and then we have gone to the second step, which is not necessary in this case. And step 3 is you have taken two pointers, left and right, such that they point to the first element and the last element like this. So we are done with 3 steps. What is step 4?
Comparing the left and right elements with the pivot element.
Right, super. You have to compare the elements with the pivot. Comparison with the pivot is the 4th step, right? So you have to compare the element pointed out by the left pointer with the pivot, and you keep on moving unless you come across an element which is greater than pivot. So what is the value that is pointed by left here? What is the value pointed by left?
2, sir.
It is 2, but the value is 0. Is it right or not? Left is pointing to the last first index, which is 0, and what is right pointing to? It is
8, sir.
So we have pointers like this. Right. Now you tell me, you compare the element 2 with 40. Is it less than pivot or not?
Yes, sir. Yes, sir.
Yes. So if it is less, what you have to do? You have to increment the left pointer. Therefore, left is pointing to this location. Again, compare the element that is pointed out by this left with the pivot. 15 compared with 40. Is it less than or not?
Less than.
Less than, sir.
Less than, sir.
Yes. If it is less than, what you have to do?
Increment the left
Increment the pointer to next.
Increment the left pointer. Therefore, the left pointer is pointing to this location. Now again compare 9 with 40. Since 9 is less than 40, you have to increment the left pointer. Right. Therefore, my left is pointing to now
60.
60. Now you compare 60 with 40. Since 60 is greater than 40, you stop the operation. As I told that you keep on incrementing the left pointer until unless than pivot. What is the value of right?
59.
No. What is the value of right?
8, sir.
8, sir. Right. What is the value pointed by right?
59.
59. Now you compare this 59 with 40. Is it greater than or less than?
Greater than, sir. Greater than, sir.
Greater than. Since it is greater than, what you should do?
Increment the right pointer.
It's not increment. You have to decrement the right
Decrement.
pointer. You have to go towards this left hand side. Right. So you decrement the right pointer. That is right minus minus. Therefore, the value becomes 7 and it is pointing to this location. Now tell me, 43 compared with 40.
Greater, sir. Greater than, sir.
So what I should do?
Decrement. Decrement.
Super. Decrement right pointer such that right is pointing to this 6th location. Now tell me, 17 compared with 40.
Less than, sir. Less than, sir.
Less than. So when you find an element which is less than the pivot element, then what you should do? You should stop the process.
Stop swapping.
And you have found, you have entered a situation where the left is pointing to greater element than pivot and right is pointing to smaller element than pivot. In such situations, you have to swap the elements pointed out by left and right. So you move 60 here and you move 17 here. So what happens here? It becomes 17. What is the value here?
60.
60. Super, right? Now you continue the process. Again, what is the value of left?
7. 0.
No. I am asking you the value of left. Value of left is 3. Value pointed by left is 17. Right. So the value pointed by left is 17. Compare 17 and 40. Since the value is less than pivot, you increment the left pointer. Becomes 4 and my pointer is pointing. Right. Now again compare 35 with 40. Since 35 is less than 40, what I should do?
Increment, sir.
Increment the left value by 1.
Pointer, such that it is pointing to 5. Now my left is pointing to this location. Now tell me, 22 is less than 40.
Yes, sir. True.
Answer.
Yes, you have to do the incrementation. Therefore, my left pointer is pointing to again 60. Now compare 60 and 40.
Greater than. 60 greater than 40.
What should I do here? You have to stop incrementing
Stop.
the left.
Left pointer.
Now go to the right pointer. Right. So what is the value of right here?
6, sir.
Sir.
What is the value pointed by right?
60.
60. Compare 60 with 40.
Greater than.
Greater than. Super. What you should do?
Decrement the right pointer.
Sir.
So decrement the right pointer. So this becomes 5. Pointers have crossed each other. This is not diagrammatically shown, but how you can identify that the left and right pointers cross each other? If you observe the pointer, the left where the left pointer value is greater than the right pointer, then you can identify that both the left and right pointers have crossed each other. Right. So when the pointers cross each other, what you should do? You should go for step 5. So when the pointers cross each other, what should you do? Now you have to swap the pivot. Now it is time to move the pivot element. Now it is time to move the pivot element and place it in the correct position. Now you tell me whether I have to swap the pivot element with the lower left pointer or the right pointer. Any idea?
Left, sir.
Right. You should always move the pivot element or swap the pivot element with the left. Why? Because see here. So if I move the pivot element with the right, let us see. Right. Let us swap the pivot element with right pointer. You move 22 here and you move 40 here. So this becomes 40 and this becomes 22. Right. So if this is the situation, as I told that the pivot element divides the given list of elements into 2 parts, and all the elements towards its left hand side are less than the pivot and all the elements towards its right hand side are greater than the pivot. Now if you look at the situation here, what are all the elements towards its left hand side? 2, 15, 9, 17, 35. Are they smaller than pivot or not? Yes. Now you will observe the elements towards its right hand side. 60, 43, 59, 22. Are all the elements greater than pivot?
No, sir. No, sir.
No. So that is not the correct movement, right? So you have to move the pivot element, or you have to swap the pivot element with which pointer?
Left.
Right left pointer.
Right,
Left pointer.
left pointer, right. The concept is very simple, Amma. You have to go in the opposite end. That means since you have taken the rightmost element as the pivot, listen carefully. Since you have taken the rightmost element in the pivot as the pivot, after the finalizing the position of the pivot, you have to swap it with the left. Since you have the right pivot element, you should always swap it with the left. But if you have taken the leftmost element as the pivot, then you have to swap the leftmost element as the pivot with the right. So if you take the left as pivot, you swap it with the right pointer. If you take the right as the pivot, you have to swap it with the left pointer. Is it clear?
Yes, sir.
So even
Yes, sir.
even when you get any confusion, you just make it in the rough sheet that whether you check whether all the elements towards its left hand side are less than, and all the elements towards its right hand side are greater than or not. Right. Now if you observe, 40 is my pivot, right? This is my pivot element. Now if I observe all the elements towards its left hand side of 40, 2, 15, 9, 17, 35 and 22, all are less than 40. Okay, done. Right, 43, 59 and 60. Okay, we are done, right? All the elements are greater than pivot. So when you have reached a position where you move the pivot element, or you have placed the pivot element at its exact position, the pivot has divided the given list of elements into two parts. How many elements are there towards its left hand side?
6, sir.
6. How many elements are there towards its right hand side?
3.
3. Stop, right? Did the pivot element divided the given list of elements into two equal halves?
No, sir.
No, right? So the choice which we have taken, which is the rightmost element for this given list of elements, is not the best choice. Not that much good, right? Is it clear?
Yes, sir.
Yes.
Now what you have to do is, you have to take the left subarray, listen carefully, excluding the pivot value, and you have to take the right subarray, excluding the pivot. Don't change the pointer values. Indexes, you should not change the indexes. What are the indexes here? And what are the indexes of the right subarray?
7, 8, 9.
Now, what is the choice of pivot? We apply. This is left subarray. We call it as left subarray, this one. And this is right subarray. Now you have to apply the quicksort algorithm recursively for both the left subarrays and right subarray. Is it clear?
Yes, sir.
Now let us do one more step. For left subarray, I am going to apply. So what is the choice of pivot? We apply the quicksort algorithm. What is the first step?
Selecting a pivot element.
Selecting the pivot. Previously, what is the method you have chosen for selecting the pivot?
Rightmost element.
Rightmost element. So for this left subarray, what is the rightmost element? This one. 22. Is it right? That means the element which is present at 5th index. Now what is step 2? Take two pointers, left and right. What is the value of right here?
4, sir.
Super, 4. Therefore, right is pointing to this location and left is pointing to this location. Now again do the same process. Compare the element pointed out by the left pointer with the pivot. 2 less than 22. What should I do?
Increment the left pointer.
Increment the left pointer. Now 15 compared with 22.
Less than.
Less than.
What I should do?
Increment the left pointer by 1.
Okay, I have incremented the left pointer and my left is pointing to second index. Now tell me, 9 compared with 22. Since 9 is less than 22, you increment the left pointer such that it points to the third index. Right. Now 17 compared with 22. Since it is less than, increment the left pointer such that the left pointer is pointing to index 4. Now 35 compared with 22. Is it less than or greater than?
Greater than.
Greater than. You should stop here, right? Now you move to the right pointer. What is the value that is pointed by right pointer?
35.
31.
35. 35 compared with 22. Is it greater than or less than?
Greater than.
Greater than. Therefore, what you should do? You should decrement the
Increment the
value.
right.
Right. Now you can observe, that means right is pointing to this location. Now you can observe that the two pointers cross each other. Right. At this position, what we have to do?
Exchange the pivot element and the left pointer elements.
Exchange the pivot element with the left pointer. Therefore, you swap this 22 with this 35. Therefore, this becomes 22 and this becomes. Now, what is this pivot here? 22. It has divided the given list into two parts. The left subarray consists of 4 elements and the right subarray consists of 1 element, which is not equally distributed. Right? Right? Is it clear?
Yes, sir.
Let us go with the right subarray. Let us go with the right subarray. The last part which I am going. Right. Now, out of these 3 elements, what are the 3 elements we have? 43, 59 and 60. Out of these 3 elements, you have to select the pivot element. And the choice of selecting the pivot element you have chosen for this example is the last element. Therefore, the 60 becomes the pivot. Is it right or not?
Yes, sir.
Now, the second step is you take the left pointer. What is the value of left?
7, sir.
7. And you take the right pointer. This is right. And it is pointing to 59. 43 compared with 60.
Less than.
Less than. Therefore, you increment the left pointer such that it is pointing to this location. Now 59 compared with 60.
Less than, sir.
Less than. What you have to do?
Increment.
Increment the left pointer. Therefore, 8 is incremented to 9. Therefore, my pointer value is pointing to this location. So you can observe here that the elements, the right, left and right pointers have crossed each other. Is it right or not?
Yes, sir.
Now what you have to do? You have to swap the pivot with
Left pointer element.
left pointer. Pivot is same and the left point is pointing to same location, right? So it has divided the given subarray. Initially, I have the right subarray with 3 elements, and after I place the pivot with the correct position, the left subarray consists of 2 elements, and the right subarray consists of null elements, 0 elements, which is having, right? So I apply again the quicksort algorithm for these 2 elements, and you apply the quicksort algorithm for this subarray, and then this subarray also you have to do. Right. So how can you do it for this subarray? We have only 1 element, right? How can you do sorting or apply the quicksort algorithm on this? So what is the pivot element here?
35 itself, sir.
Pivot element is 35, right? So you will get confused whenever you come across a single element. That's the reason why I'm saying, right? So this is pivot. So what is the value of left here?
60.
No. What is the value of
Nine,
left?
Nine.
Null, sir.
I'm asking you about this single element. How can you apply the quicksort algorithm for this single element? Right. Listen carefully. Up to this point, you are clear, right?
Yes, sir.
Now you have moved 20 to its correct position, 40 to its correct position, and you have moved the 60 to its correct position. Right? And the remaining elements 2, 5, 9, 17, you have to apply the quicksort, and for 35 you have to apply the quicksort, and for 43 and 59 you have to apply the quicksort. You don't get any confusion when you have more number of elements, but let us consider the single element part. When you apply the quicksort for this single element, you have to, the process remains the same, but you don't get confused, right? So I'm explaining the part of applying the quicksort for the single element. So what is the index I have for 35?
5, sir.
What is the index of 35? It is 5. Right. So this is this is a subarray consisting of single element. So what is the pivot value here?
35.
You have to take the last element is nothing but 5 only, right? What is the value of left here?
5, sir.
Super. What is the value of right?
5, sir.
5. Therefore, both left and right are pointing to the same location. Now you go for the third step. Compare the value of 30, the element pointed by left with the pivot. So if it is less than or equal, you can go for anything, right? It is less than or equal to, or you can go for this right, which is greater than or equal to. Right? So if it is less than or equal to, what you should do? You should increment the pointer. Are you getting my point?
Yes, sir.
Right.
Yes, sir.
So this becomes right. So this becomes 6. So when the 2 pointers cross each other, you have to swap the element with the pivot element. So 35, we have only one element, right? 35 swapped with 35. Therefore, the element remains the same and it has occupied the correct position. So can you apply the quicksort algorithm for the remaining subarray, that is 2, 5, 9 and 17 and 43 and 59? You have to apply it recursively such that you will get the sorted list of elements. So this is how you apply the quicksort and you implement the quicksort. Is it clear?
Yes, sir.
Yes, sir.
So you should remember the steps. The first step is you have to select the pivot element. The selection of pivot is of your choice. The step 2 is you have to move the pivot element. You have to move the pivot element to one end of the array, either to the leftmost end or to the rightmost. After that, you have to choose 2 pointers, left and right, where left is pointing to the leftmost element and right is pointing to the rightmost element, other than the pivot, and you start comparing the element that is pointed by left with the pivot. Similarly, you start comparing the element pointed out by right with the pivot. So whenever the element pointed out by the left is less than the pivot, you keep on incrementing the left pointer. This incrementation should be repeated until unless you come across an element which is greater than pivot, And when you go for the right pointer, the element, if you find the element that is pointed by the right pointer is greater than the pivot, you just decrement the right pointer. And this decrementation should be continued unless you come across a position where you have find an element which is less than pivot value. So if such situation comes, that means whenever you find these two elements where the first element is greater than the pivot pointed by the left pointer and the second element is less than the pivot pointed by the right pointer, you swap these two pointers and you keep on doing the same process, repeating the same. Right. So at one position, the two pointers cross each other. At one position, the two pointers cross each other. At this point, you have to swap the pivot either with the element pointed out by the left or with the element pointed out by the right, which depends on the implementation. So once you move the pivot element to its correct position, then you can observe that the list of elements has been divided into two equal parts, where the left part consists of the elements which are always less than the pivot, and the right part consists of elements which are greater than the pivot. So once you have done with this, you get two subarrays, the left subarray and right subarray. You apply the quicksort algorithm recursively for the left subarray and right subarray and you apply it until you arrange the elements, all the elements in the given list in the sorted order. Okay. So this is the all about the quicksort algorithm. Is it clear?
Yes, sir.
Yes, sir.
This is the end of the quicksort algorithm. In the next class or in the next session, we will discuss one more important sorting algorithm, which is insertion sort, and if time permits, we will also discuss the mid sort algorithm. Right. So that will be the end. Yeah.
సార్ ఒక జనరల్ డౌట్ సార్, మీరు ఫస్ట్ సెమ్ క్లాస్ ఈజ్ రికర్షన్స్ చెప్తున్నప్పుడు రికర్షన్స్ చాలా స్లోగా జరుగుతాయి అని చెప్పారు కదా సార్.
Yeah. Please tell me.
రికర్షన్స్ చెప్తున్నప్పుడు రికర్షన్స్ కొంచెం స్లోగా జరుగుతాయి, అంటే స్టాక్స్ లోకి హీప్స్ లోకి వాల్యూస్ అస్తమానం చేంజ్ అవుతూ ఉంటే స్లోగా జరుగుతాయి అన్నారు కదా సార్. మరి ఇదే క్విక్సార్ట్ ఎఫిషియెంట్ అల్గారిథం ఎలా అవుతుంది సార్ ఇది రికర్షన్ మీద బేస్ అవుతున్నప్పుడు?
Whenever that's the good question. Whenever we are asking, yesterday we have a discussion on this particular topic. I think you are not there for it, right? So whenever we have the recursion mechanism, I'm saying that recursion mechanism involves function call. Whenever a function call is involved, it involves a lot of stack operations. Is it right or not?
Yes, sir.
Stack operations means we are increasing the space complexity, but not the time complexity. What is stack?
Space, sir, and the memory, some space.
It is nothing but the memory, right? So when you keep on pushing and popping the elements for n number of recursions, so we have to create n number of steps. You have to create n into n number of push and pop operations. So that makes you to increase the space. So you are going to increase the space for n number of recursive calls, n stack creations you will make, right? So that increases the space complexity, but not the time complexity.
Time complexity. Okay. Clear, sir.
So time complexity is always measured in terms of, I told you, what is the important criteria we should consider for the time complexity?
Big go, sir.
It is bigger is the notation, but what you should consider for considering the time complexity? Is it
Comparison,
the real?
sir.
Super, right? It is the operations, not only comparisons. It is how many operations you are performing here. Here, the operation that you are performing is comparison. So, how many comparisons you are doing? That is the thing you have to consider for the time complexity. Is it right? Is it
Yes,
clear?
sir. Clear, sir.
So today, this is the end of our today's session. We have completed the quicksort algorithm. So if time permits, you please try it out with an example. You take one old question paper and you take an example from that one and you practice. Practice makes you perfect, right? So thank you one and all.
Thank you.
థ్యాంక్ యూ